Hello, my name is Arkadiy Kukarkin, and I'm here to talk to you about the joys and pains of working with decentralized technologies at the Internet Archive. So you probably know who we are, but just in case, we're probably best known for the Wayback Machine. We've been archiving the visible internet since 1996. So whitehouse.gov. Here we have it from 1998. We actually have it from before, but that version didn't look very interesting. We're also a real library with actually a physical space as well that looks like this. And we have books, we have audio recordings, we have film, we have ROMs of old games and software, just about every medium type you can imagine. We really try to be a universal library. And we're not without our quirks. For example, as a 3-year job perk, you get a half-size terracotta statue of yourself made to be put into the Great Hall of the headquarters. So that might give you a little bit of context for what the organization is like. So why are we here at Web3? It might be a little bit hard to see, but we have a particular motto, which is universal access to all knowledge, which, if taken literally, can present certain problems, but we broadly stand it. And we've been involved in the space for some time now. Since about 2016, we've been running a series called DWeb Summit, named thus in part to allow this fine event to have its namespace, but also to indicate an inclusion of a variety of peer-to-peer technologies, as well as power balance technologies and thought frameworks, in addition to what we think of as Web3, which is a little bit more of a crypto-focused narrative. So here is our team at 2016, the first Builders Day at the first DWeb Summit. You might see some familiar faces. Over there, we've got Juan, we've got Feroz, but we also have Tim Berners-Lee and Vint Cerf. So it's really a joining of generations of pioneers of these technologies. And the series has continued. This is from last year. We now do camp formats, and as you see, it's grown quite a bit. I welcome all of you to join us at the next edition, most likely the next year. Okay, so what is our motivation for working with these technologies in the first place? I would say it's twofold. One side is an idealistic drive to provide a better internet, better web for all users. So the primary concepts in this idealistic strain involve individual data sovereignty and privacy. These are, I think, cornerstone rights to a healthy digital ecosystem of any kind, and should be table stakes. They also involve the balance of power. We're very concerned with the classic big tech situation that we end up with over and over again in a variety of subfields. And we're also very concerned with interoperability as being essential to these other two goals as well. However, we also have an applied angle. So we are a working library. We serve tens of millions of users, and we do want to have these technologies work for us in some capacity. And this gets a little bit contentious. And as a caveat, this talk is my personal interpretation and not an official view of the archive. But I think the two things that we're concerned with and that this set of technologies could really help with is storage and transmission of our archival materials. So this is high volume stuff, hundreds of petabytes, high cardinality, meaning we have tens or hundreds of billions of individual records, again, depending on how you count, and we have a very long tail access pattern. So we have things that are never accessed, we have things that are in extremely hot storage, and there is not really a very clear separation between the two or a good prediction strategy. And lastly, content authentication and access control is something that's very important to us. And whenever you see a double asterisk like this, that means that could be its own separate talk about double the length of this current one. So what have we done so far? The first project that I worked on at the archive was IPFS. So I was actually working at Protocol Labs at the time, handling a number of partner integration, deployment initiatives. And what I saw was this one in particular, was that it was just stuck, and it needed someone really committed and really well-informed in both domains to make it work or to at least approximate that. So after getting through the kind of surface problems, we ended up with some deeper ones. The biggest one is that the cardinality of our primary keys was about the same size as the entire IPFS DHT at the time, depending on how you count, but it was certainly within an order of magnitude. And furthermore, to announce the provider records to actually make the content available on the IPFS network, even for 1% of our content would take more than the lifetime of those records of 24 hours. And the block store that actually stores the data on the back just could not keep up with the scale that we're trying to work at. Notably, as of today, a lot of these problems have been solved, and they've been solved in kind of a funny way, which has basically been moving to giant nodes and abandoning certain concepts that had been kind of integral to what people thought of as IPFS some years prior. So for example, the DHT has been substantially supplanted or at least supplemented by IPNI, which is basically a giant machine that knows where all the blocks are. Theoretically, this is federated. In practice, it's a little bit unclear. The actual data providers have also been moved, or the larger data providers have shifted to a pattern that has been called in some circles elastic IPFS, which again involves removing a lot of the guts of the system and giving out the block stores, storing raw cars in S3 buckets, and using range requests to read the block data back. Funny enough, that's actually very similar to how the Wayback Machine works. We have our crawl data stored in work files, and we request the relevant segments through range headers. So this might actually be something worth revisiting very soon. The next step, which was logical in some sense, which is basically that if we can't necessarily serve the data today, we could at least try to store it, is Filecoin. A key thing that I would like to remind you is that Filecoin and IPFS are largely unrelated concepts that just happen to be joined at the hip in an organizational sense. And if you've seen me talk, this is probably something that you've seen about, and this is probably another double asterisk here. So how have we done with Filecoin? Well, it's a little bit hard to say because a lot of the onboarding happens through aggregator on-ramps, which we stubbornly refuse to use. We insist on using the protocol pretty much directly and doing our own data preparation and working directly with service providers. Nonetheless, we are currently, I believe, the second most expansive institutional user of the system with some tens of thousands of deals and petabytes stored and on-chain. We also run a small in-house mining operation, which is very experimental. As you can see, this is an actual machine with a drive array on top. It's in a little closet at the church that is our headquarters, housed behind a rack of servers through a hidden door, kind of a Narnia situation. And this actually maybe makes sense for us because we are very stingy with our storage generally, so we keep 2 copies of everything and don't use erasure coding or any fancy techniques like that. So perhaps a 3rd copy that sort of pays for itself and has something resembling what we call fixity in the archival sciences could be a good play, and we're ramping this up, but it's still very small. It's only about 100 TIPS of power. We've also worked with a lot of other storage technologies. So WebTorrent, very portable, very small. This is actually live for any given archive item today. Small tip, an unofficial feature is that if you upload a bare torrent file into an Internet Archive network or item, it will actually pull down the contents of that torrent into the item and then also act as a web seed. Yeah, you can play around with that if you want. We also use tools like storage, which actually mostly just works. It hasn't been super exciting, but I find it to be a pretty good system. We've used that and HyperCore and that whole family of tools, which have a lovely but very small community, low usage, and no sustainability model for their development. So unfortunately, that is largely dead. And we've also played with things like Arweave, which is just incomprehensibly tiny compared to the amount of data that we would actually need to store. By the way, if anyone here is from CO Walrus, come talk to me. I would love to have a chat. So the problems that we've encountered with many of these technologies along the road sort of tend to follow the same patterns. And the biggest one is that they're built with too many assumptions. They're almost always developed by teams working with a pretty much unlimited budget of EC2 credits or other infrastructure on demand that they can deploy just at the scale that they need to see fit, or else they have bare metal that is spec'd exactly to what the tools demand, which is actually not how most real-world organizations are going to work. There's also a lot of assumptions about egress. People are very confused when they look at our near terabits of interconnect and then look at the transfer speeds. And the answer is very simple. Well, people are using all of that interconnect to get to the content. And lastly, storage mounts, kind of a small technicality, but everyone assumes that you have a nice file system that you can read from quite fast, and that has all of the nice flags and all of the things that you expect from a real file system. Well, actually, not every situation will be like that. This is why we like some of the tooling in the Filecoin world, which is based on Arkclone, which provides a level of abstraction and compartmentalizes some of the finer access details and allows the community to contribute. The second problem that I've seen time and again is overspecified implementations that were made in a kind of a clean room environment without talking to the users or rolling out minimal implementations. So a great example of this is the Filecoin storage and retrieval markets, payment channels, GraphSync. All of that stuff took a huge amount of work. It was mostly ripped out, decommissioned, deprecated, or otherwise unused. So please ship your mainnet with simple primitives. Let the users find their path with it. And OK, this last bit is cut off. But the promise of a lot of these systems is that they will undercut the storage costs. And even with the subsidies that we see for many of these systems, our storage cost is $500 per terabyte per 100 years. Usually when you show that to people working in the space, they walk away wide-eyed and unable to comprehend how we do it, which is actually by having a class 0 data center with no air conditioning, no backups, using the spinning disks that are highly cost optimized, and having highly dedicated staff. So some of the other work that doesn't necessarily touch upon the main domain of storage that we've undertaken or thinking about is one is Tor, which you don't necessarily think about in the DWAP context, but is very much a network in that spirit, and certainly embodying a lot of this, the ideas of privacy that we are also concerned with. So we have a Tor Onion service that has had a lot of optimizations done for separating and identifying the traffic such that you don't get throttled just by sharing exit node with an abusive user and so on. Just go to archive.org in Tor browser or Brave, smash the purple pill in the title bar, and it'll take you there. TLS Notary, this is another big double star that connects back to some of the authentication contexts. So we have a user-sourced, we call it archive team, crawling arm, where we will archive a site such as Flickr, if there is a kind of a 5 p.m. on Friday downtime on Monday announcement, and a service like TLS Notary can theoretically allow us to authenticate those crawls and bestow them with a similar status of authenticity or source of truth as our own crawls. But we do need to be convinced, because our team is a little bit old school. So talk to us, come to us, convince us that the cryptographic proofs provided by such a system are actually important. I believe that, but not everyone does. And aside from this, there's a lot of other stuff. So as a trivial example, you can store your Genesis block with us. You don't have to. We don't want to be kind of just a generic free storage for everything, but culturally significant things such as Genesis blocks. Absolutely. come to us, bring them, stick them in an item, we will sign off on them. Another thing that I should have put a double star on is gated access and compute over data for ML. We are obviously, as mentioned in the previous talk, a large source of training data for all sorts of models. And while we work in a private public service, we are not actually a fully world-readable resource, and we also exercise some amount of rate limiting and so on for abusive or overly enthusiastic consumers. So thinking about how to package that data, how to gate access to that data, and how to bundle it with compute over data for training is a really high priority for me personally. So if you're interested in that, also, please come and talk to me. Indexing and preservation of Web3 content is another one that has been on the back burner. Of course, there is a lot of services such as NFT storage, new Web3 storage, et cetera, that will provide a subsidized permanent storage for you. But can you rely on that? Can you rely on that type of organization to actually provide long-term durability? That's an open question. I think our mandate puts us in a distinctly different and distinctly more durable position. And lastly, we're very open to experimentation, and we would like to experiment more with different modalities. Anything that you see sticking into or sticking with our principles that I outlined at the beginning is fair conversation. Talk to me, talk to our founder, Mr. Bruce O'Kale, and there's a pretty good chance we'll host a node or at least give you some brutally honest feedback.